This video is on how to multiply a decimal by another decimal. And to do this, we're just going to have a look at a couple of examples. Now, there's a fixed method that I can teach you to multiply a decimal by decimal, but I'd rather you understand what's going on. And in order to work out what's going on, we're actually going to change each of these decimals, 0.3 and 0.7, into fractions. So in this little red box here, I'm going to write a few things. That's not part of your solution, but it's part of your understanding. So 0.3, we can see there's a 3 in the tenths place, so we have 3 tenths. And over here we've got a 7 in the tenths position, so we've got 7 tenths. And we can see if we were to multiply these fractions, nothing can cancel. So we're going to have to multiply our numerators and then multiply our denominators. When we multiply our numerators, 3 sevens are 21. So we're going to end up with 21 or 2 and 21 in our answer somewhere. So the first step in this method of multiplying decimals is to ignore the decimal place. So you're often told, just have a look at the numbers that exist without the decimal place. There's a 3 and a 7 and then multiply them. But we know this question isn't 3 times 7, it's 0.3 times 0.7. So the question is, where does the decimal place go? And the decimal place, well, that question can be answered by looking at my numerators here. From the first fraction, I picked up 3 tenths, so that we get tenths from the first fraction. We also get tenths from the second fraction. And if I multiply tenths by tenths, I get hundredths. So it turns out I have 21 hundredths. And 21 hundredths looks like this, 0.21. So that's the final answer to my question. So I put it back in. I don't know why it's disappearing. 0.21. Now the question is, sorry, it's playing games with me. How do I put the decimal place back in without converting my decimals to fractions each time? Well, what students are often told to do is once you write down 3 times 7 is 21, you start at the end of the number, which is where the decimal place currently is, and because there are 2 numbers after the dot, so there's a 3 here and there's a 7. There's 2 numbers that come after the decimal place in both the decimals we're multiplying. We take 2 steps to the left. 1, 2. And we know that when you take 2 steps to the left, that's the same as dividing by 100, which is exactly what we're doing over here. We are dividing by 100. We can see that here because we've got 10 times 10, which is 100, but it's in the denominator. And so that, in the end, is the same as dividing, as we've got this dividing sign, dividing by 100. So, in summary, you can first multiply the 2 numbers as if the decimals don't exist. That gave us 21. Then you can count how many numbers are after the decimal places. So we've got 1, 2, and then you can move the decimal place 2 places to the left, like we did here. 1, 2, and put down your new decimal place. However, I do want you to understand where the 3 times 7 came from and where the hundredths came from. Let's have a look at another example. Here we've got 2 wholes and 56 hundredths. I'm going to times that by 0.4, which is 4 tenths. If I change this mixed number to an improper fraction, it's 256 all over 100 times 4 tenths. So, straight away I can see that I need to multiply 256 by 4. And that is the first step in doing these kinds of questions, is to ignore the decimal place. If you ignore the decimal place, you get 256 by 4. So we're going to do that over here. 256 times 4. 6 fours are 24, carry the 2. 5 fours are 20, plus 2 is 22, carry the 2. 2 fours are 8, plus 2 is 10. So we get 1024. Now we know this is not 256 times 4, it's 2.56 times 0.4. So let's work out where the decimal place goes. We've got hundredths from the first fraction, tenths from the second fraction, and that makes thousandths altogether. Well, if I wanted thousandths, the dot would go here, 1.024, which is the same, let's see, I'm not sure why that happens, which is the same as 1 whole and 24 thousandths. Now, just to remind you of how you do this without writing out the fractions, is you count how many numbers are after the decimal place. We've got 1 here, 2, 3. Then we start at the end of the number because that's where the decimal place currently is, and we move it 1, 2, 3 places to the left. Now, moving the dot 3 places to the left is the same as dividing by 1,000, and that's exactly what we're doing over here. Okay, if we look at the bottom of the fractions, dividing by 100 and dividing by 10 is the same as dividing by 1,000. So that's why the dot ends up where it is. Let's do this last example just the quick way. Okay, I'm not going to convert to fractions this time around. We look at the two decimals and we write out the numbers as if there are no decimal places. So that's 371 times 96. Okay, that's clearly not something I can do in my head, so I'm going to multiply it out. 6 1s are 6, 7 6s are 42, carry the 4, 3 6s are 18, plus 4 is 22, put down my 0, 9 1s are 9, 7 9s are 63, oops, fix that 9 up, carry the 6, 3 9s are 27, plus that 6 is 33, a little bit out of my box. Add the two rows together, 6 plus 0 is 6, 2 plus 9 is 11, carry the 1, 2, 3 and 1 is 6, 2 and 3 is 5, and I've dropped the 3 down. So we end up with 35,616. Now, just a reminder, we weren't asked to do 371 times 96. We were asked to do 3.71 times 0.96. So we're going to think about the fact that, oh, actually, no, we'll finish off the question using this quicker method. We're going to count how many numbers are after the dot. So 1, 2, 3, 4. So we can start at the end over here where the decimal place currently is. I'm going to jump 1, 2, 3, 4 and put in my new decimal place. So we get 3.5616. To think about why, well, we've got hundredths from this fraction and hundredths from this fraction. And hundredths times hundredths will give me tens of thousands, which is exactly what I've got in my final answer.